Hey guys, this is your Madam Vash and welcome to my channel.
In this video, I'll be guiding you with answers and explanation from Quizizz 7.1 Acid and Bases. So let's start the practice. According to Arrhenius theory, an acid is a substance that produces hydronium ions as the only positive ion in an aqueous solution. Next, identify the combination that makes an acidic buffer solution. Here you have to recall that an acidic buffer solution is made from a weak acid and its conjugate base, in other words, its salt. So let's identify weak acids. The first option, yes, HNO2 is a weak acid and NaNO2 is its conjugate base, so that would apply. The second option, we have CH3COOH, ethanoic acid, which is a weak acid, and CH3COO2 Mg is its conjugate base, so that would make an acidic buffer. The third option what we have is hydrogen fluoride and sodium chloride. Yes, hydrogen fluoride is a weak acid and NaF is its conjugate base. Fourth option, we have ethanoic acid again, but now it's together with a neutral salt and it's not its conjugate base, so the fourth option does not apply. And the final option is actually a combination of weak base and its conjugate acid. So the answer would be just the first three. Acetic acid, which is a weak monoprotic acid, and its concentration is 0.2 molar. The Ka value is given to be 1.8 times 10 to the power of -5, and we are required to calculate the pH value. The pH value is calculated by using the formula negative log base 10 concentration of H plus ions. Where are you going to get the concentration of H plus ions? You are going to use the ICE table, and I will be showing you the calculation. So the answer is 2.72. Which of the following salts form an aqueous solution with the lowest pH value? So here lowest pH value means it must be an acidic salt. An acidic salt is made from a strong acid and a weak base combination, and that would be NH4NO3. Which of the following salts have pH lower than 7? So again, you must select an acidic salt. So let's look at the first option. NaBr is a neutral salt because it's made from sodium hydroxide, a strong base, and hydrogen bromide, which is a strong acid. KCN is made from a weak acid, HCN, and a strong base. Magnesium sulfate is again a neutral salt. C6H5NH3NO3 is actually made from a strong acid, nitric acid, and a weak base, which would be C6H5NH2. And that would be our answer. The last option here, we have CH3COO, which comes from a weak acid and a strong base combination. So there's only one answer for this question. So which of the following does not make a buffer solution? So please remember, a buffer solution is made from a weak acid and its conjugate base combination, or a weak base and its conjugate acid combination. So the first option is a combination of weak acid and its conjugate base, so that makes a buffer. As for the second, HBr is a strong acid and NaBr is its salt, so that does not make a buffer. The third option what we have is a weak acid and a neutral salt, and that does not make a buffer. The fourth option is a weak base, C6H5NH2 is a weak base and its conjugate acid would be C6H5NH3Cl. So that makes a buffer, and the final option also makes a buffer. What is the pH of 1.56 times 10 to the power of -6 molar solution of HCl? Here, Do recall that HCl is a strong acid, therefore 100% dissociation occurs, and 1.53 times 10 to the power of negative 6 molar would be the concentration of H. Negative log base 10, this value would give you an answer as shown in the calculation, 5.82. How would you calculate Kb for the formic ion given that Ka for formic acid is to be a value 1.8 times 10 to the power of negative 4? Here we will be utilizing the auto-ionization of water equation. As you know, Kw equals to Ka multiplied by Kb. Therefore, Kb would be Kw divided by Ka, option 3. Here's an extra question. Why were the biological samples generally good buffers? Because all living organisms need to maintain homeostasis in terms of pH. So what does the equation in the image corresponds to? I think this is an easy one, so it corresponds to Ka. Identify the combination that makes a basic buffer solution. So it must be a combination of a weak base and its conjugate acid. First option, yes. Second option, yes. Third option, yes. You should recall that ammonia and amine derivatives make weak bases. So which of the following is not an Lewis acid-base reaction? As you can see here, the option would be 3. Okay, carbon plus oxygen producing carbon dioxide is actually a combustion reaction and it's not related to acid and base. Which equilibrium corresponds to the dissociation of a weak acid HA? So firstly, make sure HA is placed as reactant. Next, add water. So that leaves us to option 2 and 4 as answers. The product would be the conjugate base, which is A minus, and hydronium ion. So that would be answer 4. Which of the following salts has pH equals to 7? So that must be a neutral salt, which is magnesium sulfate and also sodium bromide, made from strong acid reacting with a strong base. A buffer solution is made by mixing HA, weak acid, with its salt containing A minus ion. Identify the formula that can be used to calculate the pH of this buffer solution, and the formula is actually the Henderson-Hasselbalch equation, which says pH equals to pKa plus log base 10 multiplied by the concentration of conjugate base over weak acid, and the answer would be first option here. The pH value of a solution of sodium hydroxide with concentration 2.5 times 10 to the power of negative 3 molar is. So first of all, you must realize that sodium hydroxide is a strong base, therefore it undergoes complete dissociation to produce hydroxide ions. Concentration of hydroxide ions would be 2.5 times 10 to the power of negative 3, and we can calculate pOH from there. Since the question is asking for pH, it would be 14 minus the value of pOH as shown in the calculation, and the answer would be 11.4. The magnitude of Kw indicates that water auto-ionizes only to a very small extent. This is because the value of Kw is 1 times 10 to the power of negative 14. In which of the following aqueous solution does the weak acid exhibit the highest percentage of ionization? As we know, higher value of Ka indicates higher percentage of ionization. In other words, higher concentration of H plus ions. So from these options, the highest percentage of ionization would be from HF, which has a Ka value of 6.8 times 10 to the power of negative 4. What is meant by salt hydrolysis? So salt hydrolysis occurs when there is a reaction between cation or anion or both with water. The concentration of OH minus ions is given to be 4 times 10 to the power of negative 9. So what is the pH of the solution? Here you are required to calculate the pOH first, then calculate pH by 14 minus the value of pOH. That would give us the pH of a solution consists of CH3COOH with concentration 0.02 molar and CH3COONA with concentration 0.01 molar and a Ka value of 1.8 times 10 to the power of negative 5 is, here you must realize that this solution is actually a buffer since CH3COOH is a weak acid and CH3COONA is its conjugate base. Therefore, in order to calculate pH of buffer solution, you must use the Henderson-Hasselbalch equation as shown. Thus, the answer would be 4.44. A solution of weak acid with concentration 0.2 ionizes 1.8%. Calculate the Ka value for this. The calculation is shown in insert. Therefore, the answer would be 6.5 times 10 to the power of negative 5. So finally, which of the following salts have a pH more than 7? So this must be a basic salt made from strong base and a weak acid. So the answer would be CH3COOK and KCN.
Thank you for watching this tutorial. I'll see you in the next.